Hi, and welcome to the second gravity engine tutorial, where we'll look at some of the basics of the gravity engine and how to create a system of binary stars. As before, we need to have a gravity engine in the scene, which we can add through the menu. And just to show some of the basic capabilities, we'll grab 2 copies of the star prefab we made in the first tutorial. We'll move them so that they're at -10. Move the other one to +10. And then we can just press play and see what happens. And so the gravity engine detects them, evolves them, and as they go through each other, what happens is something that's common in gravitational physics simulations, which is there's a numerical instability, there's a time step where there's a really big force applied, and they shoot through each other, and energy conservation is lost, and they go flying off to infinity. There are a couple of ways that can be dealt with. The first is just by detecting a collision and stopping them before they get that close. And there's another tutorial where we'll talk about collisions as a solution to that. In the specific case of 3 bodies, there's a special integrator that you can use with Gravity Engine under the Advanced tab, where you choose Algorithm, but it applies only to 3 bodies. There is a choice of a adaptive time step integrator called Hermite, which will make the problem a little bit better because we'll adapt the time step as they get close together, but there will still, if they move directly through each other, be an issue with them flying off. So energy is being handled much better by the Hermite integrator, but we are making the CPU do more work as they get close to each other. So let's set that aside for now and just go back to the standard leapfrog, which is a very computationally efficient algorithm if we're not going to have too many close encounters. So one way to avoid close encounters would be to have these objects be in orbit around each other. So what we'll do is we'll give each of them a velocity. We'll give the first one a velocity of -4 and the other one a velocity of +4. This way we make sure that the velocity of the center of mass is still at 0, and they won't drift off out of camera range. And then we can press play and see what kind of orbit we get. And so we have 2 stars of equal mass moving around each other. If you had a particular orbit you were looking for, you would have to tinker a fair bit with the velocity to get exactly what you wanted. So to make that less of a trial and error process, Gravity Engine provides a script which we can attach. First we'll just make an object to hold it. We'll call it binary pair. Then we'll add a component, scripts, first in the list, binary pair. So here are all of the attributes for elliptical orbits, and binary pair expects to have 2 children, so we'll take these stars, make them the children of the binary pair, and then say, let's have the binaries in an orbit of, say, 10 units around each other, maybe 20. Now we can do all the same things we could do with our planet orbits, but they will affect each of the objects in the binary pair, including tilting. And in the case where we make one of the stars a different mass than the other, when we look at binary pair, they will both orbit around their common center of mass, and the heavier object will have a smaller orbit. So this controls the physical scale of the orbit, but this may not be the time that we want the orbit to evolve on. We might want them to move a little bit faster. One way to accomplish this would be to just go into each star and change the mass of each star by the same factor, and then what's going to happen is the speed of the orbit will change according to that. In fact, according to the square root of the increase, if you want to get precise about it. However, this is a common enough thing that you want to change the way the overall scene evolves. The Gravity Engine has a scaling component built in, and you can scale either the mass or the time or some mixture. If you change this mass scale value, all of the masses in the scene will be multiplied by that factor. So if we change it to a factor of 5, what will happen is the orbit will speed up by a factor of about √5. And what's happening there is the integration is running at the same time step. We're using about the same amount of CPU. The forces are larger. The objects move a little faster. If we set that back to 1, the other alternative is we could increase the time scale by 5, and this will increase the evolution literally by 5. So things will move a fair bit faster. But this is causing the CPU to execute more time steps on each fixed update. So depending on how many objects are in your scene and what effect you're looking for, you could use either of these options or some combination of them. And that's a short illustration of how to create a binary pair using the gravity engine. Thanks for watching.